Okay. Hi, everyone. I'm Shrey,
And I'm Arthur.
and today we're going to be talking with Bhairav Mehta. And our podcast is 20 Time Horizons, where we're going to have the conversations with the people who are building the future today. And so we wanted to get right into it. And, why don't you tell us a bit about yourself, Bhairav?
Yeah, first and foremost, thank you both for having me. So I am I guess, computer scientist is the general title I give. I am a PhD student on leave at Massachusetts Institute of Technology. I did my master's at a place called Mila. It's a Quebec Artificial Intelligence Institute, and I'm a proud Wolverine alum from the University of Michigan, class of 2018. And yeah, I build algorithms, or I try to build algorithms in the machine learning space that do a very particular type of machine learning, focusing on something called multitask learning. So yeah, otherwise, just love the outdoors and, just generally happy to be here. So thanks for having me.
Great. Yeah. And so, I think one of the things we wanted to dive into right away is, we've become really interested in education systems and education more broadly, the pitfalls and also the benefits of the systems that we have today. And I know you're interested in that space, and we want to get, a high level overview of what you think education is and the goal of education and at the different levels of schooling as well, and where you see, the pitfalls as well as the perils of the systems now.
Sure, and I'll try to keep this focused because I did prep a little bit of this answer, but I like to extend that and say, like, this is really the only thing I care about. Machine learning is cool, but really the whole point started from this like seed of education. And education is one of those crazy things, right? Like, you can walk into a physics class at MIT, you can walk into a machine learning class at the University of Toronto. And let's say you brought someone back from like the 1800s, right? The only thing they wouldn't recognize equations, they wouldn't recognize what people are using, like what people were wearing, but you could walk them into a lecture room and say, like, this is where we have lectures, and they'd be like, yeah, I knew that, like, this is what we had before. And it always just kind of seems strange of, like, we have all this cool progress, like, we have iPhones, we have computers that are doing, like, things that are unthinkable at this moment, right? Or like even 5 years ago, we have those computers sit in our laptop or, in our homes today. And it's always just like, why has education looked the same? And this is what we care about. It's like, how do you take technology and dump it into education, right? And it sounds like a very, easy thing, and I think there's lots of really cool people doing things like this. And there's, people like the Khan Academy, like schools, the labs and stuff. But what I particularly care about, and we'll hopefully get into this a little later, is education needs to, it has a system today. And what you see out in places like Silicon Valley and, generally places, around these extremely intellectually like diverse areas, is that they're able to throw out the system and say, you know what, we are going to do a micro school. We're going to do like an interactive learning school, and we're going to rebuild this from the ground up. But what about all the people, what about everyone else, right? The idea is that we have hundreds of millions of students in school today who are just learning by lectures, and the more time we waste on not integrating technology into those classrooms, the worse and worse this will become. And this is what I care about in education. It's like, how to take an education and scalably integrate it into the systems we currently have. And yeah, so.
Yeah. And just out of curiosity, oh, sorry, go ahead, Arthur.
Yeah, so I was just going to ask, when you talk about like moving beyond the traditional lecture model, could you just talk briefly about what you think the functional limitations of that model are? So obviously, there's a lot of cognitive science out there identifying various like plus and minuses. What in your view is the thing that we should be trying to increase the most by using new techniques? Like, what's the metric, or what's the it might even be more abstract than that, but yeah.
Yeah, and I think a lot of people are doing, a lot of these new school systems are taking the right approach, and they're saying, okay, there has to be an interactive component. So there's tons of research that says that here's all the different ways you could learn, and we basically use the worst one, in the sense of worst being the metric of knowledge retention. I'm going to give you an hour and a half of just random stuff, not random, but like effectively, whether you know it or you're behind, you're ahead, everyone's getting the same thing. and then you basically just, you go in an hour and a half and you are expected to know at the end. What we care about is actually that, like, closing the interactive loop and saying that, okay, well, at least the first step is get a gauge of everyone where they actually understand things. And this, I think, is firmly within the technology that we have today, is trying to better understand where people's like knowledge gaps are or skill gaps are. And then I think what you actually do is close that loop. It's like, how do you actually integrate that type of metric into technology systems for personalized learning? But one of the things I'd like to highlight is that we have teachers, we have professors that even if you just gave them that first part, these are people who love teaching, who, you know, they're giving up their lives to teach. And even if you just gave them that, they're more than capable of adjusting their own classrooms and things like this. And I think that's the first thing we need to care about. It's like, how do you actually highlight and build systems that highlight these kind of gaps that are different across each student? You know, before even getting to like, how do you actually get these kids to learn what they actually need to? Because I think that's a really hard technology problem, but I think that first part is actually a little bit simpler than most people think.
So it almost sounds like diagnosing the student before even trying to, provide them with the treatment or whatever it is, as if if what they're learning is that treatment needs to be done. And there's just a lack of, pre-diagnosis on, where is this student in the setting. And I want you to go back, what motivated you to get into education? Like I think the goal of education right now that we're trying to, the political systems are trying to make is that it's more personalized, it's more equitable, it's more affordable, both at different levels within the systems. But what made you want to be someone to drive change in this space?
Yeah, and I think people have a lot of really positive ways of going about this. But really, it kind of started from like much earlier on, right? I was always like interested in tutoring, right? But tutoring back in high school was just the easiest way that you could make money. It was, I worked at a Jamba Juice for like $9 an hour, but if I did SAT tutoring, I'd make 40, right? So
Yeah.
back then it was like getting into it was just like, well, how do I have the most money to buy like the new Halo that comes out? Oh, it's
Yeah.
tutoring, done. But then it slowly got into it. So I went to the University of Michigan and I was sold on being a chemical engineer. I was like 100%, there's no way I'm not doing a PhD in chemical engineering. I don't have a PhD in chemical engineering. But really it was those classes actually that was like, and it kind of stemmed from like, I'm paying $55,000 for the University of Michigan. $65,000 is my tuition check. And I'm getting this. This is what I'm giving. That the lecture would be just given. It would just be like, here is the lecture. I have 10 minutes for questions. It doesn't even matter if you know, kind of do it or not, or like understand what I just said. And realistically, I mean, it was kind of naive at the time. I just thought looking back, I was like, dang, like this is how every single thing I've ever learned was learned. Is that people just gave out tests. But I figured like, well, you're going to good universities, there's got to be something different. And when there wasn't, that's when it just like all that kind of like pent up, like, man, this is like a waste. It just kind of just like, okay, well, this is stupid. Like we need to do something about it. And that's when you really go into, well, like I'm obviously not the first person and hopefully the last person to have these thoughts, but like people have been trying. And then that's when you like really start to understand the intricacies of how difficult this problem is from both the technology aspect, but also all the way up to the implementation and all these little things that go in there. So I spent the last like 6 years just trying to figure out like the whole gamut of that. But it really started off with just like pure spite of me coming home and saying like, dude, I cannot believe I just paid for this. Like what?
Yeah. Arthur, how many times have me and you complained about that in the past
Yeah.
2 years of like, hey, this was a useless lecture, or I could have picked and learned that in half the amount of time in a textbook, or there's better resources from MIT OpenCourseWare that all of us are using, yet we're still paying for education that I actually drew an analogous thing. Like, I have subscriptions to Netflix, Spotify, and all these different platforms, but the one I use the least and pay the most for is my education and online. And like, it's sad that that's the case. And I think the people who are realizing it, I think, are definitely the people who are more self-aware, more and more, because it's very easy for people to conform to this I need to do it because my parents said to, or I need to do it because everyone around me is doing it. How do you engage people into being more self-aware and thinking about the education from the ways that we want it to be personalized, more effective? Because I think that that's something that, and Arthur, maybe would you agree? Like, it's just hard to convince people that be self-aware, think about what you're doing, like, because they just fall into this trap, for lack of a better word.
Well, yeah, I think there's like two levels, right? Like one is like the level that I think we're talking about here, which is like how do you increase learning, and then there's the whole like education system around that, which I don't think we're going to get into as much today. I think we're probably going to focus more on like the learning side.
Right.
Yeah.
And and full disclosure, right? Like I teach, and my lectures were never perfect, and there's a lot of pressure on academic
Yeah, for
professors.
sure.
For sure.
And again, like they, even going down to like high schools and like middle schools, they have metrics that they have to maximize. And well, how do you do that? I'm not saying it's definitely not on them.
Yeah.
And the other issue I have, I wouldn't say I have, but like the other thing is that it takes a level of privilege, I would say, to actually sit there and say, hey, like this is silly, right? Like if I had to go to college, like, knock on wood, I didn't, but like if I had to go to college to get a job so that I could, pay back all my tuition and make sure my family was secure and wealthy and, stuff like this, then I don't have time to like care about why I'm doing this. It's just like the test is next week.
Yeah.
I have to do it. And this is kind of the trap that I think even like higher education gets into generally, is that you're already squeezing out some portion of the population to get to higher education. You're squeezing out another portion of the population to get to like, how do you reform higher education? At the end of the day, like the people who are sitting there trying to reform education from a technology perspective, or internally at these organizations or universities, like we all come from the same background. And then that kind of defeats the purpose, right? Because the way that you reform it is by engaging as many people as possible from as many diverse backgrounds. So you have to like almost go all the way back. And that's why you can't really, I don't think you can even say like, how do you get people more self-engaged? That by the time that we're ready to have these conversations and like try and turn people one way or another, it might already be too late. But
like because inherently, like if the learning is the problem that you're thinking about, then you're already like quite far down the funnel, right? Because like often it's a lot more like fundamentally like economically driven, or people in tough situations, and like to be able to think about learning as the bottlenecking problem is quite like position of privilege for sure. Definitely agree with that. But just like kind of getting more specific now,
Sure.
could you talk like briefly about like what your current project is in this space, and what you've done before as well, specifically?
Yeah. And again, right, we now, so I run a small company, and I'll talk to hopefully a little bit about how we got to this point, right? Going from PhD to this, but we now focus on a company called Q&ai, and we build basically our tagline is like LinkedIn skills assessments for any documents that you might have. And what we are really focusing on is how do you get people to read things or watch videos and ask them questions that highlight exactly what I was talking about first, is that those underlying latent skill gaps, or like differing skill levels of different things. And this is what we focus on now. So I write a lot of code that tries to take in raw text and condition it on certain source documents and stuff like that, but trying to figure out how can I use the interactive loop that people can have by, again, speaking to computers or typing things in to computer, like answering a question, and try and highlight and understand those latent skill gaps. And this is what we kind of really focus on. And by understanding those latent gaps, right? So Arthur, you might know calculus 1 super well, right? But you might not know calculus 2 super well, whereas Shrey might be the opposite. Understanding that, I think those like latent skill gaps, and of course it would be fine grained, is how I can start to build a personalized learning system and say like, Arthur probably needs to focus a little bit more on X, whereas Shrey might need to focus a little bit more on Y. And this is exactly what I do today. It's like, how do you find to the bare minimum, like, or try to find a, these like value or the latent gaps between people. And then basically what we do is we present them to human beings, and the human beings who are training, again, we're in the corporate education space, but training people, they take that and they run with it. They know exactly what they want to do with that information. And that's where we kind of draw the line between where technology kind of is today and where it could be in the future, if that makes a little bit.
Yeah, so just so I'm understanding, so you're basically trying to say, okay, given some document of text which encapsulates some body of knowledge, you're trying to figure out between what a certain person's skill level is in that by generating questions based on that and then asking them and having them answer questions based on that. Is that good?
Yeah, and we don't even actually, we take a step back, right? There's lots of cool work going on in question generation. Again, we use human beings, right? Like humans love to teach. So we actually ask them to type in the questions they want. And then what we do is we run our algorithms to basically say, this document or these things that you've just put in, this is what we think the knowledge contained in it is, and this is what we think the relative importances of those pieces of knowledge are. They sit there, they edit it, and then we just ask the user. And again, this is where one of my personal favorite things about this type of system is that every single part is human in the loop. And this, one, engages all the people who are involved, but two, it makes the technology problem so much easier. So we can actually make progress on some of the stuff we talked about a little bit earlier.
Yeah, that's really interesting. I think I would definitely benefit from that, actually, even in like the non-corporate setting, even just like day to day. Like, okay, I watched this lecture or even read this piece of the textbook, generate some questions, and then find those gaps, because it's very hard to find your own gaps without understanding and testing yourself iteratively. No, that's a really cool project. I'm curious to know where you see it's like impact being beyond the corporate, or is it focused on corporate? Like, what's your target demographic of people, and is there a goal to maybe come to more traditional academic settings?
Yeah, and this is a perfect question. And to be honest, right, we're a young sort of group of folks trying to build something, and that means you have to, building stuff for the normal education cycle. And we tried to do this for 3 years, and there are a lot of like economic issues that go on. There's a lot of like bureaucracy things that kind of, you know, they kind of serve as blockers in some sense. And this is where we made our shift to corporate education pre-pandemic. So if we had just waited out a few more months, maybe it would have been different. But this is exactly where we see ourselves. It's like basically all we care about is how do you get people to learn anything better. That's it. Like, so whether it is students, whether it is corporate professionals, to us it doesn't matter. But we're looking for people who need to care about actually understanding material. And this kind of X's out a whole class of folks who are just doing things for certification, right? I'm watching things on 2x speed and mute, and I'm just like clicking the little thing at the end and saying, look, boss, or like teacher, I got my certification. This is not what we kind of cater to. We're looking for how do you drive deeper understanding complex subject. And this kind of goes into, I'm sure you've all heard like the Richard Feynman quote, where basically he's like, the TLDR is that you need to teach something to really understand it. And effectively, you yourself are the easiest person to fool in terms of understanding, or like your level of understanding. And the only time you get real feedback is either when you take a test, which is too slow of a feedback loop, or teaching someone. So what we've done is built a system where you can sit there and try and teach a computer about things. So
interesting. Yeah. And
so I'm
sorry,
curious to know, so what do you think is the role of memorization in learning and education? So obviously, you're doing these questions. Like, I'm curious to know, like, are you asking them just after someone's read something? Are you trying to like space them out? I don't know if you've seen some of the work about like spaced repetition systems, that kind of thing. Like, I'm curious to know, like, what exactly, is your opinion on it, is that kind of rote learn the formula by yourself, is that useful? Or like, what's your opinion on all that?
Yeah, and Arthur, great question. And I think this, I hate to like bring it back to like what we were talking about earlier is like the education system. And I
Yeah.
think that the reason rote memorization works, um, and when I say works, is that there are places like MIT, there are places like Stanford where the students have learned, like people like me have learned through rote memorization, right? I'm going to do as many practice problems as I can. I'm going to read,
Yeah.
memorize as much stuff as I can. And people make it to these institutions and do genuinely good science.
Yeah.
So on one hand, it definitely works, right? Like we're making
Yeah.
cool progress in everything.
Yeah.
My issue with memorization is that it weeds out too many people, is that the learning capacity for people is much higher than we think, and it's not being engaged by memorization in the sense that you're definitely going to get the cream of the crop when you just go memorization, but eventually you're going to, kind of lose out on people who, with a little bit of push it, or I guess a little bit of like alternative learning, or like a little bit more time, could have also gotten to that like MIT, Stanford, U of T, all these like top institutions
Yeah,
doing.
I definitely just follow up on that. Like, I definitely agree. Like, there's a ton of super smart people who just whether it's because they can't do it, whether it's literally due to something so dumb as they never ended up cracking that. Like, how do you study for an exam? Like,
Yeah.
you just lose them, and then they get discouraged from doing these subjects that they could be really good at. But yeah, I definitely agree. On the other hand, I do think like being able to memorize something is definitely key to being able to also hold it in your head. So I think uh, going back to like what I was saying about like the spaced repetition stuff, at least personally, I've found that super helpful in understanding stuff long term, like where you kind of review flashcards at increasing intervals and that sort of thing. Yeah.
And I think, yeah, spaced repetition, like it like definitely works. Yeah, I think there's got to be a mix of both, right? What we're basically doing now, even spaced repetition is kind of like a fringe technique, right? You're like,
Yeah.
and like, someone tells you about it, you learn it. The
Yeah,
one,
exactly. Yeah.
um, but yeah, I think there's a lot of cool little things that we can be doing right
Mhm.
now with technology, or just research in like educational psychology, that can be implemented into the current workflow that we have, where we don't need to rip up a
Yeah.
school and like put in a new one, where we can really make a good impact on like people's lives like this, if that makes sense.
Yeah, so just to make sure I'm fully understanding everything we've talked about so far. So we've highlighted that there's a lot of friction in the way we learn as well, in that it hasn't changed through time. One of the problems is diagnosis in learning, which is where are the gaps, and the feedback systems to make sure that we can fill those gaps are currently either they have too much of a lag, or there's friction into engaging within them, whether that's through testing or whether that's through teaching. Q&AI is helping find a solution to that gap by proposing the user to ask questions to make sure that they understand content. And then there's a whole other bucket of problems from like the learning space, but then the systems that promote or house these learning, which is like education systems, the incentives within them, as well as whether we can. This is I feel like a totally different topic of like financial incentives, whether we can talk about income sharing agreements and other ways to promote learning in other ways as well. And I just want to make sure. So there's like basically two buckets within academia that people are working on, and maybe obviously a lot more, but the ones that we're talking about today, which is like the learning itself and the systems that operate within that learning.
Yeah, absolutely. I think that's completely right. Yeah, we're mostly focused on like the technology, whereas the institutional and systems level change, I think I would love to be involved, or like people I know who are building technology like me would love to be involved, but we just don't have like the street cred to like kind of make change in these ways,
Yeah.
which is why a lot of people are doing these types of things in the event that you can slowly move up the stack and say, I want to impact at larger
Yeah.
level.
So like this brings me back to another question I had for you, because I know that you're also working with the Rethinking ML workshop for iClear. And for people who don't know what that is, it's basically a workshop to find new ways that we can reform machine learning, create different, correct me if I'm wrong, incentives and ways that people can, create maybe content within the space that diverges from maybe the ways that we're currently doing it, as there's inherent problems. Maybe we can go into that a bit later.
Yeah.
And so I'm also just curious to know, like, there's this problem of status and power to create change in systems when you may not be the big names in machine learning, or you may not be the big names in education. but you're maybe a student, or you're even where you are in your education career. And this goes back to even if you're not familiar with Intellipedia, it was an organization that was trying to be created before 9/11, which is communication between FBI, NSA, and all these different institutions to communicate. And the individual who was pushing for it was just a basic level agent who she was trying to push for creating these communication channels via the internet, but people didn't want to create it via the internet, and so they decided to do this all handwritten. And that lack of communication potentially could have helped with the 9/11 crisis. Everything changed after that. Intellipedia was created. She was the head of Intellipedia, but she didn't have the status nor the power before 9/11 to drive that change. But what we're seeing more and more now is like people often think, can I challenge the academic institution as a second-year student? Probably not, because I don't have status and power that maybe a professor or even the dean of engineering may be able to have. How do you approach that with your company, as well as you more broadly, which is, there's friction points with maybe us getting into traditional academic systems is going to be a lot more challenging than to us to get into the corporate systems because of the bureaucracy within that. It's no different than the legal frameworks, healthcare frameworks, and other verticals where there's a lot of friction. And so I was wondering what your high level view is on like how to create change when you don't have status and power, or is it something that you just have to be patient with and just try to build clout and get the name for yourself as well?
Yeah, and there's definitely a little bit of, so my answer is build technology. You know, I think especially if you if you can code, right? Here's a good example. I think if you can code, you can basically push apps to millions of people. You don't have to ask anyone for permission. You don't have to ask anyone to do anything. This is the best way, right? Like let effectively the market figure out whether your product is good or not, or whether the ideas driving the product are good or not. And this is kind of where we got to, is that at q&ai especially, it's like we just, why don't we just see if this works? And I guess going back to the rest of your question, like how do you do that from wherever you are? I I think the best way to do it is that, and I've had this conversation with a lot of people who are doing their masters, their PhD, where this like intense level of focus is required, right? And you can't really be like running around and like, I want to touch this project, touch this project. It's just that trying to like figure out what you care about and being super loud about it. So like for me, it was always education, and I would have the coffee chats with people, like telling them like basically what we're talking about here. And I think that eventually that people start to listen, and if they don't, screw it, just go out and do it yourself. And I think that people like us actually have a lot more power than, let's say, our parents or that previous generation did at that age, where the only alternative was to like rise to the ranks and then affect change. Whereas we can kind of short circuit the entire thing by building a startup, putting something like random workshop on the internet, right? Effectively, this was just the main lead of this, Krishna. He just texted me on Slack and we put it on the internet, right? Like, and then all of a sudden you guys know about like what this is. Like, that's crazy, right? And I think that a lot more people are starting to use these channels. There's things like Kickstarter are built on this idea, like Product Hunt. Just like put your stuff out there and let people figure it out. And if you're in an academic institution or some like organization, just pick something that you actually care about and then just like be loud about it. And I think eventually that kind of like helps the progress. And I think a lot of people kind of get afraid of that, especially in academia, in the sense like, oh, I can't care about this because I have to publish my paper at ICML. Like,
Yeah.
sure, I get it, but like, as long as you only care about like one thing, that kind of helps there. Is like find what you care about in academia or in an organization, and then just like don't shut up about it if possible.
Yeah, and I think that really is really good advice of don't feel limited by whatever your current context is. The internet can go anywhere. And I think probably Shrey, despite being the one who asked the question, probably knows this better than anyone else, because I guess you might have seen this Bhairav when like looking us up, but like Shrey helped start this organization called Flatten, right? And basically like the main aim of that was to try and collect data about COVID-19. And the app, I was also involved in it, but he was the main lead. The app got over 400,000 submissions, more than the Ontario government's
Yeah.
accepted in the same timeline, right? So, and you know, that some of the data internationally that we collected as well ended up actually being used for resource distribution. And we don't have like medical backgrounds or things like that. But we're taken seriously by medical people simply for the reason that we were building something that was useful. And so I definitely agree, like, it's very easy to get negative and say, oh, this system is broken or that system is broken. But do something about it, you know, don't just sit there and yeah, you have the skills and the power if you can code. I definitely agree with that message. And I think it's a really good positive message to stop people from getting like stuck in a rut of like, oh, you know, everything's terrible. And yeah.
Yeah. And so just a bit of context, Arthur and I are still getting, you know, into the academic space, trying to learn more about the people, the systems, the incentives within them. And I was trying to learn more about the mission of, you know, also rethinking ML and analyzing the different ways that researchers move forward. And I think we're transitioning from education now into sort of the research space, for context for the audience. And so I think what I'm trying to better understand is, what are your thoughts on bibliometrics as they are right now and how they drive incentives? I think it's a very debatable topic as well. And like, how do we, what's an alternative? Like and how do they drive change and drive innovation for groups, labs? And we're still trying to better understand it because we recognize we're still limited in our experience, but coming from your experience as well, we want to just get a better understanding of what your opinion on that is.
Yeah, I think it's awful, really. There's nothing about it that makes sense. And I mean, so I understand the idea. It's like, this is a cool metric, right? I look at Yoshua Bengio's, right? When I looked at like Mila the first time someone at the University of Michigan explained it to me, I was like, who's it headed by? Yoshua Bengio. Here's Google Scholar. Very cool. Wow, like he's done, it's like a really, like, you can see the impact that he's had. The issue comes though with what you have today, is that you basically have, you know, powerhouse schools, powerhouse groups that are just pumping out papers, and pumping out papers meaning like, I mean, like hundreds of conference even. And if you like sit there and you think about it, like, I haven't done 100 of anything in a year, right? Like I have no, I don't have enough focus, but I'm out here like trying to read like 30 books this year, and people are writing 100 papers at a conference. And this is where you can really, like, if you know what you're doing. And what I will say is that I think people have this idea of academia that people don't know how this stuff works.
Yeah.
And I think that's completely wrong, because I knew how it worked. I knew my colleagues knew how it worked. And basically what happened with me was someone at the University of Michigan told me internally, like, we can't accept your application to do a PhD here if you don't have papers. And I said, well, I mean, I've been working with this group and stuff. And they're like, oh, that doesn't matter. You need a paper basically to get past the initial screening process. And I've talked to people at MIT, people at Mila, and I've asked, like, how like strict is this rule? And people will tell you, like, yeah, not really, but like, people look at H indices, they look at citations. These are things that can be hacked. And you know, when you're telling students who want to do a PhD, like, to do research, that like, oh, we can't accept you unless you effectively hack these metrics, then you have this like sort of feedback loop that kind of grows. And I think it's horrible. I can get, sorry, that's like a mini rant, but
so I think, yeah, I think I agree, like it's terrible, and like there is all these bad incentives, I guess. And also I agree, like people are much more aware of the problems in academia, or else, like, if people didn't know what the system was, they wouldn't be able to exploit it. Like, first of all, the thing is, I wonder, like, maybe kind of going contra to what we were saying a few minutes ago, is there actually a way to kind of move beyond that context? Because it seems like everyone knows that that's the system, but because like there's real money involved, like especially if you're doing research, you need to dedicate like a huge amount of focus, as you were saying, to it. Is there a way of kind of going beyond it, or are we stuck with that system? And I was wondering, like, then how does that tie into like the context of this workshop you're helping organize on alternative publication formats as well?
yeah, I think there's the most beautiful way, and I think people like Semantic Scholar have given this a shot. And if you look at Semantic Scholar versus Google Scholar, you'll see that the citations are actually listed by order of impact, meaning that if you cite my paper, but it's just saying like someone did some random thing in domain randomization, cited. This is actually a much less impactful citation than, oh, okay, we're building on top of someone's work. And that second citation should actually count more in some sense. And having almost like shifting it to an impact score. And that's where I think you can really get around the like hacking systems. Because even if you are a group that's publishing, or a university or something like this, who's publishing like 50 papers at ICML or some random conference, as that should be okay as long as you're like building on that work and that previous work is impactful, the work you're citing is impactful. If you're just citing it so like, oh, okay, I have another citation here, that should be discounted. And I think that's where, I don't know how they do it, to be frank, but like the folks at Semantic Scholar I think are moving in the right direction. It's like, let's start to gauge impact and basically build like an H-index around that. Is like, it's the same idea. It's like maybe a different score calculation, but you've had X amount of impact on papers and work past that.
That's really interesting. So it sounds like you do actually think that you can kind of technology your way to solve this problem with better metrics, right? That aren't so susceptible to the same problems that citations are. And maybe going forward, those metrics could almost use some of the same or like same kind of machine learning or natural language processing based techniques in order to actually improve the way we score things. So maybe actually that's like a positive thing to, like maybe that's what we're learning in this discussion is you can actually really do a lot more with technology and solve a lot of problems just by trying to improve on existing systems.
And Arthur, I think I agree. Like I totally agree with what you're saying. The issue though is then how do I care about and I think Shrey brought this up, is that there's real money involved, right?
Yeah.
So how do I run the Beyond the paper workshop with my friends and get someone who's getting a grant to care about it? Or how do the people at Semantic Scholars say to the NSF, like, don't use H-index as a like key metric inside of your grant like scoring, but use our more impact driven one. And that's where I personally, again, I think that really shifts. We talked about the two buckets and the two verticals. So like there's technology, you can build technology all you want, but until you like shift it over to the organization and the institutional side, it's all kind of just sitting there. So that's where I don't know. And I hope, you have to get buy-in from people who are on that side, but that's where I definitely think that there's a limitation to even the stuff that we're trying to do. Is that this is really cool. You'll have some really pretty exhibits and I encourage you both to check it out. But at the end of the day, how do we actually get something like this to actually drive impact beyond having a workshop?
Yeah. And I feel like that's something we're seeing in almost a lot of the high deep tech verticals, whether that be climate, healthcare, legal. I remember my comments before is like policy / people in those systems will be critical to large scale deployment to like the target audience. And like, that's something that we're seeing is a very timely topic for those listening to this right now. Like recently we're seeing some people in the tech industry who are considering running for politics in the US, like whether that's Chamath Palihapitiya for governor in California, and like that or potential governor, whatever it is. And like, I think what's really interesting is like, how do you get people who actually understand the problems and want to drive change into those systems? There's just a fundamental, problem we're seeing in policy. I don't think we want to talk about that as much in this conversation today, but I think that definitely acknowledging the fact that politicians were there to drive ideologies and not necessarily fix problems as much due to like the bipartisanship that we're seeing grow. But I think that it's very challenging for people like ourselves who are trying to create tech, create meaningful impact, and not have the people who are almost the bottleneck solvers, not necessarily bottleneck solvers, but drive and really create that change at a scalable level in these high friction environments is definitely a big challenge that we need to find ways to engage people with that status and power to help us with.
And I guess the last comment I'll make on that is that, and this is where I say, like, at the end of the day, just go build it. Because if it's cool enough, you'll get into a room with anyone. And most likely, it's not like well, maybe a good example might be Uber or like Lyft, right? Those see like they're just building a product, right? And then it's like all of a sudden they're now in the decision making rooms for like transportation or like.
Yep.
So at the end of the day, it's like you don't screw it, just build it first.
Yep.
And people, and if it's a good idea, people will like it. And like if it's not a good idea, iterate on it till you get to a point where people like it. And hopefully that'll be enough to bootstrap your way up the ladder instead of trying to like send cold emails to get people involved. Like hopefully they get notice of it by just basically putting it out into the market and seeing if people like it.
Yeah, for sure.
Okay, so I guess maybe moving on to our kind of next topic that we want to talk about is, so you do a lot of work, I guess, in multitask learning and reinforcement learning. So I guess we had a few questions about that. So first of all, I guess for listeners who don't understand that field as well, I think it would be good for you to provide a brief description of how do you see like what reinforcement learning is, and then yeah, and then we'll move into kind of your thoughts on the field in general.
Sure. So reinforcement learning. So I guess we can start with like, what is machine learning? Machine learning, most people think of like is what's we call people who know is called supervised learning. Is that I'm going to try and learn a black box classifier or something that can basically what we call fit a data set, meaning that anytime I give it a picture, it'll tell me it's a dog, it's a cat, or it's a car or something. And that's really cool. But the issue with that is that what we have are data sets. And what we've seen obviously in the past is that people grow these data sets to enormous amounts. And we have really cool things now. Reinforcement learning is different in the sense that I don't have a data set. All I have is the environment, right? And effectively what happens is that I need to figure out what's going on in the environment to build effectively a data set that I can use to learn about what should I do in the environment at all times. Now, obviously, that's a simplified answer, but the idea is the goal of reinforcement learning is take an environment and learn how to operate in it optimally. And this is usually driven by what's called a reward function, which is often human design saying, this is a good thing, this is a bad thing in the environment, and how do I learn a decision-making, what we call a policy, based on just those signals of like, this is good, this is bad. So it becomes a very difficult problem for technical reasons, but just the fact that you have to sit there and explore the environment and figure out what's good and what's bad, and then start to think about maybe there's something better just over the horizon, and maybe there isn't. So,
yeah. So I guess then could you, like, in terms of multitask learning then, so that would be reinforcement learning, but you're trying to achieve multiple potential objectives, or how would you describe that in relation to?
yeah, great question. So we've done multitask learning in the context of supervised learning and reinforcement learning, but the idea is that you're trying to do two things at once or three things at once. And yes, Arthur, as you said, in reinforcement learning, you're trying to optimize two objectives at a time,
Yeah.
or three objectives at a time, meaning that you're trying to learn how to push and pull, like an object, like, or maybe a drawer. Like you're trying to learn how to both open and close a drawer. And I guess for the viewers who are not so familiar, yes, that is like a super hard problem to learn how to do both. But yeah, that's kind of the idea, is that like reinforcement learning at its most basic is learn how to push a drawer. Multitask learning and reinforcement learning is also, I want you to learn how to pull a drawer. So my particular area of research was actually mostly focused on, if I wanted to get to do both, should I teach it how to push first, or should I teach it how to pull first? And this was it. This was literally the entire problem. And I told my advisor, if I can spend 5 years on this and make some progress, this will be fantastic. We'll have tons of papers. We'll have all this cool stuff. But this is how hard the problem is. And in my opinion, also how nascent that field of multitask learning is as well.
And so you're working on also making that more interpretable. So being able to find a formula to do multiple tasks and seeing what the relationship between what the inputs the agent gets is and what the outputs that it gives is. And so I guess to clarify, like interpretability would be being able to define that relationship, because in most machine learning algorithms it's quite opaque, I guess, what the relationship between the inputs to the, I guess it's almost like a black box, right? What the inputs are and the outputs are.
Yeah,
Um,
and interpretability is a huge aspect of machine learning in lots of different places. We cared about interpretability in a more prescriptive sense that said that if you now have basically how are tasks related to each other, so meaning that like more in the context of the learning agent,
yeah,
why is it learning to do X and Y, but not Z. But if I show it the opposite order of what we call a curriculum, meaning that if I show it X,
yeah,
Y, and Z, it learns X and Y, but not Z. But if I show it Z, Y, and X, it can also learn all three. We were really interested in the interpretability aspect of that, and trying to formalize this a little bit more mathematically, and understanding what we call the geometry of tasks, meaning like how are X, Y, and Z actually related in like a very mathematical sense, if that makes sense.
yeah. And I'm interested to know, like, because obviously, there's a lot of, I guess, interest about reinforcement learning, like being transferred to the real world. And do you think that interpretability is that a way that we can make that a possibility? Because one of the issues with a lot of machine learning systems is because you don't know what that relationship is, it's very hard for you to say, all right, like the system is safe to be used, let's say in a self-driving car, or, in an autonomous drone, or even, if it's being used as like a recommendation algorithm, is it's, what are the actual weights that it's putting on things? So I'm interested to know, is that a possible way of define, like letting the agent basically inform you what those relationships are? Does that actually help with that? Or are the formulas, I guess, produced so complex that a human couldn't understand it? And then when it gets like more to like the level of you're defining more of like an equation like you'd see in physics that's very simple, does that then take away from the power of these machine learning techniques?
Yeah. Good question. I don't know too much. But I actually sit on the latter end that as soon as you try to make it purely human interpretable,
Yeah,
then you lose some of the power. Now, again, the group that I was, with at MIT would actually argue the opposite, is that like it's very physics driven, that you should want to learn clean physics like formulas. Um, I guess the answer that I could give, again, not knowing, the true answer, obviously, is that, hmm. So basically, I think that you won't ever get to a point where you can literally just say, here's a formula for the policy or something in reinforcement learning.
yeah,
But what I think you can do is get it certified. So there's a cool line of work in certification of classifiers and stuff. And a lot of people in control do this too, is that within these bounds of the control input, you'll never get
yeah,
any tolerance of this. And I think the coolest work, and this is being done by like control groups, like people
yeah,
at Berkeley and Caltech, is bringing those in. And I think that's probably the closest we can get, is like just having certificates of error bounds rather than like purely interpretable systems. But I think even if we could get somewhere even close to there, then compared to what they have in the control systems, you would see incredible applications of reinforcement learning in real life.
yeah. And you've also done a lot of work in domain randomization and simulators. So just to give some context, domain randomization is a technique where, let's say you have a simulator that's simulating whatever system you want, like whether it's a self-driving car, whether it's a robot doing some task, or even just like a video game environment, um, or a video game type environment. And then you want to go ahead and transfer that to the real world. Now, obviously, you're not going to have a perfect model of the agent that is in the real world in the simulator. And so domain randomization, I guess, is a technique where you randomize the parameters in the simulator. So hopefully somewhere in those random parameters, if you do enough combinations, it will be close to what the agent will see in real life, and it can learn to adapt to different scenarios. So do you think that, how far is that technique, will that take us? Because I know you've done work on like trying to see how much it can improve those gaps. And yeah, in general, I'd be interested to hear your thoughts. Like what are the limitations even?
Yeah, I don't think it can take us far, to be honest. This is definitely 180 of where I used to be. And the issue is that the way that domain randomization actually kind of, I wouldn't say works, but the goal of it if you ask a researcher or someone who's, kind of been in that sort of
Yeah.
space, it's not that it actually understands what the real world like might be like, and like this is, the truth of it, like, I've seen this combination of the real world parameters before, but effectively changing them so many times forces you to cancel out all the noise and just focus on the task. But what people don't see is that whole engineering step prior. So if you look at our papers in this subject, you look at the folks at OpenAI, you'll find these
Yeah.
massive tables of numbers.
Yes.
Say,
Yes.
the friction of the Majoko simulator is 0.17, and then we range it from 0.17 to 0.21. Don't try any numbers outside of those.
Yeah.
And that's where I think the fact that those tables exist means to me that you cannot actually get far with domain organization. And the fact, and OpenAI has worked like this, we have worked like this, where you're trying to find basically what we call the optimal curriculum through this space. And
Yeah.
I think that'll work to an extent. Maybe you get, stuff like the OpenAI hand and stuff to work a little bit better.
Yeah.
But even there, right, you're seeing orders of magnitude more of data, right?
Yeah.
And I think that where it really needs to be is actually the focus needs to be on something called system identification. Is that
Yes.
take data from the real world and fit my simulator to it, and actually go the opposite way and saying like, give me some like data from the real world, we can grab it, and then just adapt my simulator, all these different parameters into what that most looks like, and then you do some randomization on top of it. But
Yeah.
effectively, that backwards paradigm is where I see the most value. I don't see domain randomization black box being
Yeah.
super useful, and knowing people who've done this in like a industry setting, right? Not just academia to like beat a Majoko benchmark, it doesn't work, right? Like this
Yeah.
stuff is hard, and it takes a lot of engineering time that ends up not being worth it in a lot of like.
Yeah, because if you can just yeah, I know like you've worked in some of the groups at NVIDIA, like the works like Bayes Sim and these types of things. Yeah, I guess you can do that once potentially, instead of having to every time you make a new type of environment like a hand, or versus like an autonomous vehicle having to re-engineer all those thousands of parameters. And then just one final question on this topic, I guess, is I guess it's kind of a broader question, but do you feel like how far can reinforcement learning even as a field take us? Because obviously there's been a huge explosion, I guess, in the activity in the past few years. And obviously, like, we're getting faster simulators now, which are kind of seeming to improve the task complexity of things that you can do a lot more necessarily than a lot of the algorithms, which at least to me seem like there's a lot of kind of small improvements, but then you get a simulator that's 1,000 times faster, whether it be like RISIM, Isaac Gym, these types of things. And so do you think that reinforcement learning has more progress to go on the algorithm side versus the simulator side? Or yeah, what's your opinions on that?
Yeah, and that's a good question. I don't think in reinforcement learning in like the general field, I don't think we need a ton more.
Yeah.
Um, so in the sense that even if you look at like a lot of the work that's been done recently, and I remember I was in a reinforcement learning group at Michigan. So Professor Satinder Singh, he's one of these like original folks who was, doing reinforcement learning back in the day. And we did, and this was what, like 2018, 2017, and we did like, here are some like landmark papers in reinforcement learning. And I think the only one from this decade was DQN. And the point being is that all these algorithms have kind of existed, and we're getting really cool, like you said, simulators and stuff,
Yeah.
but all the like core fundamentals are kind of the same. So I actually think that the work being done that's changing the fundamentals is going to be more important, but there's a lot of cool stuff that we can do right now with the algorithms we have. And I
Yeah.
don't, so my friend just wrote a really nice paper called D2RL. Two of my friends
Oh,
from,
yes. Yeah.
yeah, you probably know,
Yeah.
Amanka and Summer.
Sam. Yeah.
And all they're doing at the end of the day is attaching the state input to the vector. And basically what they're able to show is that they get like crazy amounts of like performance improvements. And I think that that's the type of stuff we need to start playing with, is like, what type of stuff can we give to the agent that may not seem intuitive to us, but might help it make its, kind of might help with performance, because we have really powerful algorithms right now. And now it's more just like, how can we kind of engineer them into like usefulness almost, in my opinion.
Yeah, that's a really good answer.
Just also for brevity for the audience, including myself, who may not have as much of a deep understanding of RL, I guess it might be helpful just to give a quick like maybe 1 or 2 liner, like why are these problems important, and why is, like, for example, opening and closing a drawer something that we should be putting time and energy in. Like, I know what the extensions are to that long term, but like why is that something that people should care about in general?
Great question. So robots today, and I can only talk in the context of robots because I'm not sure. There are lots of like other really useful applications, but robots are the one I know. And the idea is that if you have a robot in your house that wants to do dishes, you have to program it to learn how to pick up a particular type of dish. You have to tell it like, okay, here is the what we call the policy, but basically the controller, meaning here's how you pick up the ceramic dish. Here's how you pick up the glass one that's slightly smaller. Here's how you pick up the square one. Here's how you do this. The idea behind reinforcement learning is that you don't have to teach it any of that. You don't have to write this stuff down because this stuff takes lots of time. It's very expensive. It requires PhD people to do this. And the idea behind reinforcement learning is just that let me learn how to pick up tons and tons of plates, and then I'll know how to pick up all the plates. And that's the whole idea of reinforcement learning, is that what you get in the beginning is not nearly as good as what you get at the end. And the idea is that even if your controller, like your hard-coded controller, beats you in the beginning, it won't beat you at the end, because your controller, your robot at Trey's house might know how to pick up square plates, but my super duper robot that uses RL knows how to pick up square plates and glass plates and all this other cool stuff.
Right.
The idea is that the generalization is the goal of reinforcement learning, and that's why there's so much interest in the field today, and for the last 10
Yeah,
years.
and then I guess in terms of the applications, kind of just to add on to that answer, traditionally, on the robot side, most robots have been limited into like these factory settings. You might have a robot stamping a metal panel, which is really useful, but it's only going to stamp the same metal panel 10,000 times. And what I guess you really want to have is be able to kind of generalize into these real world environments, which are much more complex, whether it be the road network or just your house or any of these things. Yeah.
And another thing I wanted to ask now, moving slightly away from the RL specifically, is, one thing I noticed is that you're interested in, this very deep area of, research and reinforcement learning, but you also care deeply about education and you care about making learning better. And I imagine that feeling when you were in school was something that you always had about education. And I think that if anecdotally, I would say that oftentimes many students who are in the research space as well have that other social problem that they also care about, but oftentimes they're so entrenched in this academic problem that they don't get to spend time on exploring what that problem even looks like. How did you sort of bucket your time, as well as even just mindset, and saying, it's very hard for someone to think about 2 problems, even though as easy as it is, and make contributions to them in each of those spaces? What did you do to being able to dive into both of these spaces, as they seem, although closely related from a systems level, very unrelated from a technical day-to-day level type of work? And so, yeah, just sort of talking about like the divergence in like these very different areas. And yeah.
And I will say that I actually, I got lucky because my 2 areas of interest are actually quite related, and from the perspective of, again, multitask learning. So I actually picked the education thing first, and then realized like, oh, I can do machine learning like in robots in this. And the idea being that all I care about is, why do people not understand A, B, and C if I teach it to them in A, B, and C order, but if all of a sudden I teach it to them C, B, and A, they understand it. Like, this is just like a thing that you pick up when you TA, and like, oh wow, like, you're adapting your own teaching style. And that's how I got into multitask learning. So I got a little bit lucky. One of the things, the only thing I can recommend, because you're right, it's absolutely difficult. One of the things I would ask yourself is, if you do want to do it, ask yourself, well, the first thing would be, ask yourself, do I actually care? In the sense of like, it's okay to just focus on mathematics. It's okay to just focus on physics. It's okay to just focus on climate change. But the best things are done when you just pick one. And I will say that, like me, myself, I was also splitting time, and it was nearly not as effective as when you just pick one or the other. And I've had like 6-month periods where you just picked one, whether it's the education stuff or it's the research, and it was much, much more productive. So that's the first thing. Second thing is find a support group. Universities are amazing places. And I can't really extend this advice to everyone else, but maybe with the pandemic, right? People are doing all this stuff online, so you can just join anyway. But find people who care about it with you. And that's the only thing I can suggest, is that you're going to run into the ruts, and having no one else in that rut with you will just keep you there. Someone has to pull you out of ruts, whether it's your professor, your friends, or your significant other. Someone has to pull you out of there. And the easiest way to make sure that someone's always there to pull you out is by just surrounding yourself with people who also care about these topics. So if you care about machine learning, or you care about robotics, go to like robotics reading groups. And if you also care about clean water, or like how technology can be used to fight like carbon capture, go to those things. But then after that, like as soon as you pick like 1, 2, or maybe 3 things that you care about, that's it. Then you really have to sit there and also yourself prioritize. And I think those 2 things together can kind of help you, a lot of researchers especially, kind of find the time to do something other than writing papers that kind of maybe affects more people, people more generally and more
Yeah.
positively.
So
For this.
that's really interesting. And I'm also curious to know, like, one of the things we look at the most creative and most innovative people and how they have different experiences. And that makes, intuitive sense as well, of like, how can I be more impactful in X space if I have the same experiences as everyone else around me? Traditional routes might be for me to go to an engineering school or comp sci school or mathematics, and then go to a PhD master's program, work at big tech occasionally here and there. But at the end of the day, my experiences might just be epsilon delta different from like everyone else. And so by that, I guess my question is breadth versus depth as well, of like, for context, like why maybe getting exposure even within a specific field in your undergrad might be something very helpful for you to make those connections that someone may not traditionally make in their graduate school, or even in graduate school, making breadth of focus such that when you're working in X field later, whether that be in professorship or in industry, you have that breadth of experiences and tying those connections that people just maybe don't have around you. And what is your philosophy on breadth versus depth? And then how do you take action upon that philosophy?
Great question. And the issue is that breadth is never rewarded initially, right? I don't get benefit from doing what I just said, because at the end of the day, right, let's say I'm doing a PhD in machine learning, I don't get benefit right away from going to, like, let's say like a stock trading. Like my interest maybe might be stock trading. I don't get interest from going to those types of groups and meetings and meetups, because I'm now spending time away from that. But only later do you realize, um, like, oh, this stuff is actually important. And my point being is that depth is the short term, in the sense that the deeper you drive, you'll get more and more benefit. Again, assuming that you've picked something like a research career or even a job, right? Like anything really, is it rewards depth in the beginning. But one of the ways that I've personally, you know, kind of like made sure that we've done a lot of breadth, like me and my friend group, is by keeping a friend group, and like going back to that support group, in the sense of like, find people who don't care about the stuff that you care about, and go out of your way to find them. Go out of your way to go to these things that you initially may not care about, and just talk to one person there, and just keeping those people in the loop and like talking to them, catching up with the, over coffee, will give you that natural like general interest, and not help, it will ensure that you don't get kind of like too far deep into one hole. Because I actually don't think, unless you are an expert mathematician or physicist or something where you're making deep, deep, deep technical contributions in a field, then I think depth all the way. But for a lot of us, right, having that breadth will be more useful than not, especially later down the line.
Yeah, I think it's definitely easier to be in the, in the top 10% of the population on knowledge on 2 things than to be in the top, 1% on one thing. Like that's really, really difficult. So I definitely agree with that. Although, like I'd be interested to know if you have like a specific example of where you did something that was completely like unrelated to your interests, and then it kind of came back later or like provided rewards.
Yeah. Let's see. Let's just look at. Um, one of the things I tell people I guess to do is like especially younger people is like go work in customer service, right? Like go work in jobs that, what you would call like minimum wage. Like go work at a McDonald's. I used to work at like a Jamba Juice, right? And this was something I was like thrown into,
Yeah.
in the sense of like, but really you come back and, now, in the context of today, right? And I'm lucky enough to be in a position where, you know, I am a researcher at MIT, and people maybe have to listen to what I want to say for little things. Um, and now I can like push different agendas that I actually care about. So that's things like education, equity, reform, and machine learning. And people actually sit there and care. But the reason that a lot of those things stemmed from was actually that like exposure to people that you might not have met earlier. And again, there's a wonderful company, and I'm like totally blanking on the name, but the CEO, she came and talked to us in a class, and I asked her the same question. It's like how she runs a company on like unconscious biases in hiring for organizations. And the idea is that I asked her like, how do you ensure as a CEO that you don't eventually run into the same unconscious biases that everyone else does? And she's like, just go make yourself be uncomfortable like constantly. Like go to the woman in software engineering thing. Go to the like NAACP meetups for if you like live in that area. And the idea is that Jamba Juice thing really kind of lets me connect with like oh shoot, like we should care about these things because there are people out there that are much worse than me writing a paper on machine learning who are like struggling for food and work and stuff, and this is why we care about it. So it's one, motivational, but two, it's like just getting that diversity of experiences in that early age was, I think, so critical for me to actually give a shit about something like education instead of just
Yeah.
saying I'm gonna go build recommender systems, which is totally fine by the way. But like I'm just gonna
Yeah.
go and like build my
Yeah.
job and stuff like that.
I couldn't agree more with that. And I think that that's definitely been something that I've trying to embody more and more of. And I think Arthur and I, when we look at decisions, and Arthur, you can like agree or disagree with what I think, but like I think we definitely are very self-aware of like the actions we're taking and why we're doing it. Like for example, we're in a position right now, whether you're a high school student listening to this or even a university student potentially going to masters, we're thinking about what major we want to do, what area of field do we want to work in, but also the summer opportunities. And like these are times for you to be able to engage in things you might not traditionally have the opportunity to, whether it's professional, non-professional, academic, or athletic, whatever it is, gets you that exposure. And I think I've definitely benefited from that with like non-professional experiences and how it changes perspective into professional problem solving as well. And something that striving for as well of like, how can I engage myself? And you commented on, constantly being uncomfortable. I know what Arthur's probably thinking about here as well, which is like, there's this group of people that I follow and actively subscribe to, which is the Yes Theory group. I don't know if you're familiar with them, but their mantra is like seek discomfort. And for people who don't follow them, it's basically put yourself in uncomfortable situations, because the more you do that, the more comfort you'll have in general. And what that means is like, you grow when you're uncomfortable. You don't grow when you're comfortable. And I think that that's really been valuable for me. And I think a lot of people around me as well.
The last comment I'll make is that the pandemic, there's only a few silver linings, right? Like it's generally been quite bad, but one of the cool things is that people are more eager to talk to others, and taking advantage of that has been really helpful for me. Is that we've gotten people on the phone that we would never get time with in a building, and just talking to people about their day and about their lives, and this is what I do when I have to do like in our case like customer discovery, but just having the time to talk to people has been super cool. And I encourage everyone to just like call up people and like cold call people and be like, hey,
Yeah.
can I learn more about your job or your like day to day? And like, there's a lot of cool people out there with a lot of cool,
Yeah.
interesting stories to tell. So
For sure. I really agree with that. Like one of the things that I've really been like learning it over the past, even like the past few weeks is like reaching out to more people in general, I think is really important during this time, whether they be like old acquaintances that you might have fallen out of touch with, or just random people who you come across online, you like their blog, like, you know, just having like conversations, that kind of thing is really useful. So I would definitely second that opinion. I guess like one kind of maybe final question before we like wrap up would be like, I think it might be a difficult question to answer, but what do you feel that you understand better than other people? Because you've obviously had like quite a few, I guess, unusual experiences. Like you're doing this education thing, you're doing like stuff in ORL and machine learning. What do you feel you understand better than anyone else?
yeah.
Or like if it's just like a point of view or way of looking at things, or yeah.
So I mean, I would normally say education, but we've talked a lot about it. One of the things I will say is that I think I take advice a lot more seriously than most people. That like if you're gonna sit here, so I had professors used to tell me like sit here and like give me advice on this, and like reading books, and it's like, well, if you're gonna spend the time to write a book and tell me about this, like I'm just going to listen to it. And I think that one of the best things I think I mentor a lot of like younger grad students, and the only thing I can tell them is like all the advice that you get is just people, um, you know, constantly just having that problem and eventually understanding it. And they're trying to like shortcut you out of this. And this is the same thing with like being a young entrepreneur, is that you just get on the phone and ask them like, please tell me what you did wrong. And I think that's like the best part. What I've gotten a lot of value out of is like just actually listening to some of that. Of course, you're never perfect about it. You'll still
Yeah.
make the same mistakes, but even listening to half of it, like you save yourself so much time, so much sleep, and so much
Yeah.
stress and stuff. So
do you, do you do you have advice on how you actually implement that kind of stuff? Because one of the things that I find really difficult is, you know, you hear some inspirational quote, um, or you know, someone gives you some advice directly. How do you actually end up following that in the day to day? Like, yeah.
Great. Yeah, good question. And I think the best thing that I've done in the last year is anytime you go into a meeting now, or I talk to a person, and again, not doing this like a coffee shop, it's kind of weird, but like having these like retroactives in the sense of like anytime I have a meeting for q&ai, or anytime I had a meeting with my professors at Mila or MIT, it's notes, and doing this like just literally just going over the notes is on its own enough where you're like, dang, my professor just told me like do XYZ, like, and he said that 3 times because I wrote it 3 times, right? And just I feel like a lot of us don't actually ever look back at notes, and just the fact of taking notes one and then looking back over them, I think that'll get most people most of the way.
Yeah, that's a really good point, because like I always take a lot of notes, whether it be in meetings or I'm even taking notes now, like just to things to come back to. But yeah, I never end up looking over them. Like I always just let them sit there. So that's a really good tip, actually. I might implement that.
Maybe build something to like send you your notes if you take them on digital platforms, and email them. Here's a note that you took on this day. It could be interesting. Yeah. I wanted to ask you if is there anything else you want to say for the audience on like last notes and like, sharing anything. I think it's been a really great conversation to learn from, but if there's anything you think you didn't get the chance to comment on, yeah.
No, yeah, and we'll use this for self promotion, but like, our workshops should be free, and we do care about changing the way people look at machine learning research. And this will be the first one. There will be a lot of bugs, but we are bringing a lot of cool speakers and a lot of people who are thinking about a lot of the problems we talked about today. And the second thing is another piece is that I also personally on my website I do a lot of mentorship. So people who are coming from underrepresented backgrounds, who want to learn about doing a machine learning PhD, or what it's like and how to apply. I'll just use this time to just say like, feel free to email me. We do a lot of this stuff. I have a lot of folks who also are involved in this. And we're always looking for new people to help, because a lot of people maybe just don't see our websites and our message boards. So any platform we can get to kind of expand our reach, and help people out and get them to that next step, more than happy to do it. But first, then again, thank you both for taking the time to speak with me.
Yeah, for sure. And we'll definitely link to both your website and the website of the ICLR Beyond the Research paper workshop. So yeah, we'll be sure.
Yeah. And thank you everyone for listening. And we'll have show notes and everything down below that you can, check in as well to get links to everyone's websites here and to handles, and some summaries will come out a week after the podcast as well. So thanks for listening, everyone.
Thanks, and thanks for your time.
Thanks, guys.
Bye.